Hello, my name is Inte, and I will talk about the time-to-event model, SurvLatent ODE, we developed for longitudinal data and application of this model to improve prediction of time to venous thromboembolism, which refers to blood clots in deep vein and can be especially fatal to cancer patients. Our model, SurvLatent ODE, effectively addresses some of the challenges in learning from messy EHR data. In a high level, our model adopts variational autoencoder framework and takes irregularly sampled patients' data through ODE RNN encoder, which can take time-varying features measured at any arbitrary times, where the hidden state dynamics of RNN are defined by ordinary differential equations. And the encoder parameterizes approximate posterior over the initial latent state. And given the initial latent state, the ODE solver produces patient's latent health trajectory using function G, parameterized by neural networks, which specifies complex dynamics of the trajectory. By decoding the latent trajectory Z, we estimate hazard functions for predicting time to multiple events, in this case 2, as shown in the diagram. One hazard trajectory may correspond to VTE, while the other may correspond to death. Clinical events, such as VTE and death, for example, may have partially shared latent mechanisms. We exploit this intuition by allowing the latent trajectory Z to be shared across the events, while having the event-specific decoder function F to capture signals specific to each outcome. Once we estimate cause-specific hazard functions, defined in a discrete time domain, which represent rate of occurrence of event K at current time bin T, we show in the paper that you can relate the hazard functions to estimate survival probability and cumulative incidence functions to evaluate individual risk of developing each event over time. VTE, also known as blood clots in deep vein, is a fatal complication for a patient with cancer and can cause significant disturbance of cancer treatment plans. In this experiment, we show that SurvLatent ODE outperforms current state-of-the-art as well as clinical standard known as Corona score for predicting time to VTE, using the data routinely collected at Dana-Farber Cancer Institute. Our method also showed competitive performance in prediction of time to death, which is competing event to DVT. Furthermore, after performing clustering analysis on the latent implantations, we found 4 different clusters with significantly different risk for VTE over time. We also fit a simple linear model to explain each cluster in terms of known features. We show that well-known risk factors for DVT, such as BMI, white blood cell count, are significantly associated with the highest risk cluster, demonstrating SurvLatent ODE provides clinically meaningful and interpretable latent implantations. Our proposed method offers promising deep learning-based time-to-event framework for risk predictions in healthcare scenario, where data irregularity such as missing measurement and loss to follow-up are very common. Thanks for your time, and see you at the poster session.